Hello and welcome to MechLearn 360. In this video, I want to explain to you fundamental concepts and idealizations used in mechanics. So let's begin from a particle, or let's begin with a particle. Alright, so what is a particle? A particle is a point mass. In other words, it has mass but no dimension. So we consider a body to be a particle in analysis where the dimension is not of importance to us. But this is just but a particle. Look at this laser right here, a point. Okay, that's what we are saying. Now when I have several of these particles, I get a rigid body. So a rigid body is nothing but consists of a large number of particles occupying fixed positions with respect to one another. And what we are saying is that a rigid body will never deform under the action of forces. So before application of a force, after application of the force, the distance remains the same. And then a body is usually modeled as a rigid body in analysis where the dimension become important to us. Alright. Now mass is the quantity or the portion of matter which is contained in a body. Alright, space. So space is defined as the position of a point. Okay. To understand space, what we do is that we define a point by providing three lengths or coordinates measured from a certain reference point or origin in three given directions. And so space that we are talking about is what we are having around us. That is the three dimension. So you measure x coordinate, y coordinate, and z coordinate. When we put them together, we have space or three dimension. Length is actually what is helping us to describe space. And so it is used to locate the position of a point in space. Okay. Now, with this, we can also describe the size of a physical system. So you measure the length, okay, isn't it? You measure the length, so you can describe the size of the physical system. Time actually measures the duration of an event in space. Then force. Now there is a whole video on force. But for now, let's take it as force represents the action of one body on another, and then it is usually characterized by the point of application or the line of action, and then its magnitude, and then as well as the direction. Now a force will be represented as a vector. That is to say, it has a line with an arrowhead, just like any other vector quantity. A point force is like a finite force assumed to be transmitted through an infinitesimal area or point. So if I reduce the action of the force to act at just a point, then I'm dealing with a point force analogy. Alright, let's look at a particle here. So this is the particle. Everything here is like a force system. I have this gentleman pulling this gentleman pulling it. But if I assume that everything here is happening at A as it is here, then I'm looking at analysis of a particle. In real life, there will be dimensions here. But over here, I'm assuming that A is just but a point. And so that is the particle analogy here. Now look at a force here. The gentleman is trying to push this. However, the action of his force can be reduced to just a force F with an arrow line, with a line and an arrowhead. You see, everything here will be some form of area, but we are assuming it is acting at this point. So that's what we are calling the point force right there. Okay, so space is right here, so I have a point P in space. I'll measure direction in X, I'll measure direction in Y, and then I'll measure direction in Z. Okay. So a rigid body will consist of tiny particles, and these particles will not change position. If I apply the force on it, F1, F2, F3, F4, all of them together, this body is a rigid body if it will not deform under the action of all these forces. Okay, so these are the basic idealizations we use. There are some other, but for now, let's take this as the basic idealizations we have in mechanics.